Okay, welcome to this video on proof by induction. We have an example, proof by induction that 3 to the power 2n plus 2 plus 8 times n minus 9 is divisible by 8 for all n member of n. So okay, we'll start with our base case, and because we're dealing with natural numbers for all n member of n, the first natural number is 1. So let n equal 1 and see if our statement is true. So when n equals 1, 3 to the 2n plus 2 plus 8n minus 9 will equal 3 to the 2 times 1 is 2 plus 2 is 4, so 3 to the 4, 8 ones are 8, take away 9, which will give us 81. 8 minus 9 is minus 1, so that will be 80, which is 8 times 10, which is divisible by 8. So statement true. Statement is true for n equal to 1. So we know it's definitely true for at least one value of n. So we can make an assumption now. So we can assume true for n equal to k. Okay, for some value of n, and we know it's definitely true for at least 1 because we've proved it for 1. This means then that our assumption is that 3 to the 2k, substituting k for n, plus 2 plus 8k minus 9 is divisible by 8. So therefore it equals 8 times, say, p, where p is a natural number, because it's divisible by 8. So that's my assumption. But what I want to really look at is what you get when n is k plus 1. And can we show that that is true? And we can use this assumption. So 3 to the 2k plus 1, substituting k plus 1 for n, plus 2, plus 8 times k plus 1, minus 9 will be the value of our expression when n equals k plus 1. So what we now do is write that as 3 to the 2k plus 2 plus 2, 3 to the 2k plus 4 plus 8k plus 8 minus 9. So we get that. What we can now do is we can take 3 squared out of this, using the fact that 3 to the a times 3 to the b is 3 to the a plus b. So I can take a 3 squared out, which equals 9 times 3 to the 2k, and this is now reduced to plus 2. So I can do that. And then I've got 8k plus 8 minus 9. So far so good. This 9 lots of this, 8 lots of that, 8 and minus 9, I can break this into 8 times 3 to the 2k plus 2, plus 1 lot of 3 to the 2k plus 2, and then I've got plus 8k minus 9, and then plus 8, I'll bung in the end. I didn't add these because I wanted to use this, and that's quite good because that's my assumed expression at the front. We know that 3 to the 2k plus 2 plus 8k minus 9 is divisible by 8. That was my assumption, so it equals 8p. So by assumption, by my original assumption, I now get 8p by assumption. And now we see that everything has got a factor of 8. So we can take that out. And if you like, that's 8q, where q is a natural number. So statement is true. For n equal to k plus 1. So by making the assumption that the statement is true for n equal to k, I'm able to show that it's true for n equal to k plus 1 by using my assumption here. And you have to make a note of that. So we're almost done. All we need is the final statement. Statement is true for n equal to 1, and so that's the starting point. We've shown it's true for an initial value, and we've shown the inductive step. True for n equal to k implies true for n equal to k plus 1. Hence, by induction, statement is true for all n member of n, because we started at 1. And that's it. All the ingredients are put together. Okay, worth having a try yourselves. So try this. It's not there yet. Here we are. So proof by induction that 7 to the n minus 2 to the n is divisible by 5 for all n member of n. So stop the video and try that. And now that you have tried it, so many minutes later, let's have a look at a solution. So we have base case n equals 1, 7 to the 1 minus 2 to the 1 is 5, clearly true for n equal to 1. Then you have my proof here. Assume true for n equal to k, so 7 to the k minus 2 to k is 5p. Consider the k plus n being k plus 1. Take out a 7, because 7 times 7 to the k is 7 to the k plus 1, minus 2 times 2 to the k, because 2 times 2 to the k is 2 to the k plus 1. Take out a 5 lots of 7 to the k, which leaves you with 2 lots of it, minus 2 lots of 2 to the k, and then you get a nice wee factor of 2 coming out here. And you have assumed by assumption that 7 to the k minus 2 to the k is 5p, because you assumed that that was divisible by 5. Now you get this common factor of 5, and there it is, 5q. Statement's true for n equal to k plus 1. And finally, you need a proper summary of things, put it all together. Okay, I hope you enjoyed that. Bye just now.